and welcome to Progressive Education Society's Modern College of Pharmacy, Nigdi, Pune. In the e-lecture series of Pharmacognosy and Phytopharmaceuticals for the class second year Pharm D.
Bhushan Pimple. In this video, we will discuss about the iodine value. Iodine value, it is basically the number of grams of iodine consumed by fat or oil, which is taken as suppose 100 gram. That means 100 grams of fats or oil, if it is consuming suppose 15 grams of iodine, then the iodine value will be 15. Or in other words, so if we get iodine value as 15, that indicates 15 gram of iodine was consumed by 100 gram of oil. Usually the susceptible oils or the oil used for the determination of iodine value are vegetable oil and animal oil because these have high degree of saturations. Whereas mineral oils and essential oils are usually not used for iodine value determination. The theory behind this practical is uh, any free fatty acid. Let us take an example of a linoleic acid which has unsaturations. Unsaturations means presence of double bond. Now you can see in this picture there are 1, 2 and 3. 3 double bonds. Now if you want to determine how many unsaturations are there, we need to go for iodine value. So what we do is we take this oil and to this we add iodine monochloride. Now this iodine monochloride, it goes and forms a bond with the unsaturated carbons. Like this iodine will delete the bond, or it will remove the unsaturation, and iodine will get attached to one end of the double bond, whereas chloride will be attached to another end. Similarly for second double bond and the third double bond. Now this indicates that it is an iodometric titration, makes use of sodium thiosulfate. Now here the number of iodine consumed will be directly proportional to the number of unsaturations or directly proportional to the number of C double bond C in an molecule or in a fatty acid. Now, why are we doing this practical, or what are the applications of this practical? Is the iodine value is used for determination of degree of unsaturation in an acid or in a oil. Further, it is used basically as a quality control parameter for raw materials used for various cosmetics or food products, and even for finished product analysis to determine the unsaturations. Now, why we should determine the unsaturations is the unsaturated oils, they have various health benefits. You might have heard the term PUFA. Usually, most of the oils that we consume, on their packet, you will definitely find this word PUFA. PUFA means polyunsaturated fatty acid. They have various health benefits, and these PUFA acids or PUFA oils have more than two carbon-carbon double bonds in their molecule. There are two types of PUFA. One is called as omega-3 fatty acids, which you all might be aware about. Omega-3 fatty acids, which is commonly found. Then next is omega-6 fatty acid. Now these three are the basic PUFA oils present in our edible oils. Omega-3 fatty acid, the best example is linoleic acid, eicosapentaenoic acid, commonly called as EPA, and Docosahexaenoic acid, commonly called as DHA. This DHA you might have heard of in various advertisers of Boost or Bonvita or Complan. This DHA is docosahexaenoic acid. This omega-3 fatty acids are majorly found in fish oils, chia seed oil, hemp seed oil, and flaxseed oil. Further, omega-6 fatty acid is found majorly in soybean oil, rapeseed oil, and sunflower oil. The benefits of PUFA are numerous, like it boosts the brain health. That means it boosts the development of brain up to 5 years of age. Then it additionally has anti-inflammatory property. It lowers the risk of cardiovascular diseases by preventing atherosclerosis. It also prevents Alzheimer's disease and also acts as a hypocholesterolemic. That means it lowers the cholesterol level. So that is the reason the oil we choose for our normal cooking purpose should be enriched with PUFA. Now we'll have a look at the iodine value determination. Iodine value can be determined by three various methods. First is iodine monochloride method, also known as Witt's method. Then iodine monobromide method, called as Hanna's method, and pyridine bromide method. We will be having a look at iodine monochloride method. Here we will require oil sample 1 gram, diluent, that means we need to dissolve this oils in some solvent, and the solvent can be used as 10 ml carbon tetrachloride or even 10 ml chloroform will do. The reactant, the basic reactant moiety is iodine monochloride. So we need around 20 ml of iodine monochloride. The solvents used, because during this reaction there are numerous iodine fumes. Iodine being a sublime solid, it gives out certain fumes. In order to capture these fumes, or in order to hold these fumes, we need another solvent, that is potassium iodide, which is approximately 15 ml, and 100 ml of water is also used to rinse this potassium iodide. Then we will be titrating this. Since it is an iodometric titration, we will be using 0.1 molar sodium thiosulfate solution in the burette. Then indicator, since it is an iodometric titration, again starch solution is used as an indicator, because starch, it gives purple or bluish color with iodine solution. So these are the requirements. Glasswares usually burette, pipette, conical flask. Instead of conical flask, we will be using iodine flask and beaker. Now, what is an iodine flask? It is a slight modification of the conical flask, wherein it has a provision for attaching the stopper in order to prevent the escape of any fumes or volatile matters. In our case, it is iodine. We want to hold this iodine within the flask. So take this iodine flask, and to this iodine flask add 1 gram of oil. This 1 gram of oil is added. Then add the diluent, 10 ml carbon tetrachloride or 10 ml of chloroform can be used. Now put on the stopper and gently shake it, so that it forms a homogeneous solution. Then to this add 20 ml of iodine monochloride, which is our main reactant, and immediately stopper the iodine flask and again gently shake so as to form again a homogeneous solution. Now this solution or the entire iodine flask should be kept in dark for 30 minutes. So hold it in dark for 30 minutes. Let the iodine monochloride attach to the double bonds and saturate the fatty acids. Then take it out from the dark environment and into the cap of the iodine flask, which is also called as a cup top, add 15 ml of potassium iodide. See here, the stopper is in place and we have added potassium iodide. So accidentally any certain suppose fumes are coming out when you are separating or when we are taking out the stopper. This potassium iodide will absorb or will imbibe the iodine fumes, and then we can slowly release the stopper or take out the stopper. Now once you have taken out the stopper, rinse the stopper with 100 ml of water. Now you get the solution. This solution has all the ingredients present here, that is iodine monochloride and oil, which has completed their reaction in the dark environment. Now this solution is ready for titration. So we use this solution and titrate it with sodium thiosulfate, that is 0.1 molar sodium thiosulfate, which is in the burette. The normal titration is carried out, and remember, instead of phenolphthalein we are using starch as an indicator. So starch, it gives bluish coloration at the end point. Initially it can be a yellowish color or golden yellow color, but later on as the end point approaches, the solution will turn bluish in coloration. So this marks the end point. This was about the procedure. Now we will determine we will have a look at the calculations of iodine value. The formula for calculation of iodine value is 1.269 into B minus A divided by W. Now we'll have a look at each and every component in this formula. First, B. B is the number of ml of sodium thiosulfate solution required for blank. Yes, we need to carry out a blank titration as well, wherein we won't be adding oil into the flask. Only 10 ml chloroform and 20 ml iodine monochloride kept in dark condition for 30 minutes and then added with potassium iodide and water, and then this flask will be titrated with sodium thiosulfate. This will give you certain ml of sodium thiosulfate. This will require certain ml of sodium thiosulfate solution. Now next is what we have studied or seen in the previous slide, that is A. Add the sample 1 gram, then all the reagents as prescribed in the process, and then carry on the titration. So here the number of ml of sodium thiosulfate required for A, that is sample, will be less because the iodine will be consumed by the sample, whereas in case of blank there was no oil to consume the iodine, so it will require more amount of sodium thiosulfate. Then weight, W is weight in grams of the substance what you have used. Substance means oil. Generally we use 1 gram of oil. Now this 1.269, yes, 126.9 is the atomic mass of iodine, and since we are determining the value, iodine value is determined as grams of iodine consumed by 100 gram of sample, 100 gram of oil. Therefore we are dividing this 126.9 by 100 to get this 1.269. So 1.269 appeared by dividing atomic mass of iodine by 100, and 100 is the grams of oil to which the iodine value will be expressed. Remember, we are going to take only 1 gram, but we will be expressing it for 100 grams. So we are dividing it by 100. So suppose your burette reading for blank is 20 ml and for sample it is 12 ml. In that case, we will be putting all this into the formula 1.269 into 20, that is blank burette reading, and 12, that is the burette reading of this sample, divided by 1 gram of oil. So this will be around 10.152. Now this 10.152 is our iodine value for that sample. So this is all about the iodine value. Reference IP volume 1.